Hello, we are doing our first video, and the idea is to take notes during this video and put them in your comp book. So bring them to class tomorrow. You won't get credit for this until I see the notes in the comp book. Sorry, I need a cameraman, but I'm the cameraman. So, you're getting dizzy. All right, make it a little straight. I don't know if the whole board is in there. I'll be able to see if I go out of range, I think. All right, I'll have to go with that. So you're taking notes on your comp book, and you are bringing those to class. If for some reason you don't have your comp book, epic fail. No. You can write them on a piece of paper and we can staple them into your comp book, but it makes a much neater presentation and it's easier to use if you write it right into your comp book. So then when tomorrow's problems are presented, you can open your comp book and see how I showed you to do them tonight. All right, let's start down our list of topics for tonight, and I want to start a timer. I guess I've already talked for a minute or two, so to recall that. I only will take...
Teachers in the building, could I have your attention? Heads up, the church will be testing the alarms.
Oh, great.
So when you hear alarms, do not be alarmed.
All right, if the alarms are really bad, I might have to shut this down and start later, but we'll get started anyway. All right. Here are our topics for today. The first one is negative angles, and I think I've already hinted at those today in class. So just be aware that when you have angles, they can go in either direction. A positive angle starts at the positive area on the x-axis and goes counterclockwise, the opposite of what the clock does. And this would be a positive angle. So I use theta for my angle symbol normally, and if it starts here at the positive x-axis and goes like the clock, clockwise, it's negative. That's arbitrary, but we had to decide one way or the other, so a positive angle will go in this direction, and the negative angle will be measured in the opposite direction. So the angle pi over 6 indicates when there's no sign there, we are assuming it's in the positive direction, and there could also exist a negative pi over 6. Alright, so when you see that negative, you know it started here and it went in this direction. Let's go ahead, and those will pop up in our work now, so just keep them in mind, and we'll go on to the next topic, coterminal angles. Coterminal angles. And all of this you've probably heard about in geometry, so this a review, so you notice I'm going through them fairly quickly, but not so quickly if you've forgotten that you can't get it. Alright, let's say that there is a race, and the track starts here, and this is the beginning line, the starting line. Just like any angle, here's the starting line. And we'll say the race goes in the counterclockwise direction, and it ends at, this is the finish line. So if you were to run such a race, you would run through this amount of radians as you go on your track. So let's observe that, and my question is, well, it's not really a question. There was a time where everyone lined up on the starting end, the gun went off, and off they went, and they went to the finish line. But one smarty pants started here and went this direction. Did he follow the rules? Well, the rules said you start the race at the starting line and you end it at the finish line. Nobody said what direction it had to go in. So the smarty pants started at the starting line, went to the finish line just like everyone else, and he claimed himself to be the winner. He did get there before everyone else. So the rule book didn't state which direction you had to go in, so they had to award him the prize, and it didn't matter because everybody jumped on him and beat him up anyway. But the moral of that story is we have a situation where angles can do the same thing. So this angle goes all the way around like that. Let's say that's talking degrees. Degrees won't totally vanish out of our vocabulary right now, but eventually I'll just say it less and less because we do not like to speak Babylonian. So if this is 330, then this is negative 30. So if we go 330 in this direction, it's the same as going negative 30 in the negative direction because 330 and 30 would complete the whole circle of 360. So speaking of it in that direction, in that way, we say that these two angles, 330 and negative 330, have a special relationship, and they're called coterminal. So these are coterminal angles. Coterminal angles have the same starting spot and the same ending spot. Is there another that I can think of? Wish I had. I think this is another color. Let's see if it shows up on the video. Is there another way I could start here and start my race here and end here, just like these two do, and have another angle altogether, not a 330 and not a negative 30. So, how about this? What if I go all the way around? I go past. Oh, great. Does that mess up your hearing of my voice? I hope that you can still hear me. But there's a fire alarm, of course, being exercised right now. So if you would, I'll view this video later, and if it's impossible to hear me, like I can't hear myself, I will retape it. Alright, so the green, if it showed up green, we started here, we went around once, and then all the way around. And did we not start at the same spot and end at the same spot? It's another example of a coterminal angle. How could I get the value for that? Well, was it positive or negative? It went counterclockwise, so we know it's a positive number. And it went all the way around to 330, and then it went one complete revolution, one complete circle past that. So we know a whole circle, we were at 330, and we added another circle, so we end up with 690. So we have 330, negative 30, and positive 690. These are coterminal angles. So often you'll be asked, what angle is coterminal to 330? I want one positive and one negative. So notice to get this angle, I can write it as negative 30 easily, and I did that by recognizing that the difference between 360 and 330 is 30 degrees, and I know it went in the clockwise direction, so I signed it 30. So notice this pattern. To get coterminals, I did 360 minus 330 for this one. And then I noticed the direction it went in, so I put a negative sign. And then I did 360 plus 330 to get 690. So some of my students who didn't feel like understanding this concept, which is not like any of you, they would just take the number in the problem and just add 360 to it and subtract it from 360 and get the answer. So that pattern will hold true. All right, let's do one in radian measure. So does it show up over here? Let me move the direction here. How long do they have to test this? I'm down in the lab, can you tell? All right, so we're going to find coterminal angles for, let me check the time. All right, doing fine. We're going to check the time for that, and let's find an angle that is coterminal to pi over 3. So pi over 3. And the direction is find coterminal angles. And I want one positive and one negative. So I'm going to take my value, pi over 3. I like to look at the picture of it. It's not necessary, but pi over 3 is about right there. Remember, pi over 2 is right there. Pi over 3 is not quite as big as pi over 2, so you know, have a general idea of where it is on the circle. So I start here and end here. So this right here is pi over 3. So I'm going to do my negative one first. And notice I have the same starting line and the same ending line. Now I need the value of that orange. And I get it by taking one whole circle, which we learned was 2 pi radians, and subtracting pi over 3. So once around minus pi over 3 will give me the orange value, and then I remember to put it in the negative answer. It won't be negative by calculation, but I have to add that negative sign when it goes in the negative direction. So how do you take 2 pi minus pi over 3? Our fractions come out to play. 2 pi is 6/3 pi minus 1/3 pi. So rewriting them for easy subtraction, I get 5/3 pi. So this one is 5 pi over 3, and then I remember it went in the negative direction. So negative 5 over 5/3 pi is coterminal to pi over 3. And now I want a positive one, so I'm going to start here and go all the way around once and overlap and stop at the finish line. So I went one whole circle plus the pi over 3. I went one, oops, I went the wrong way. Sorry, let me erase that. That would give you a coterminal angle, but it would not be positive. So let me write that in again. All right, here is pi over 3. And now I want a positive one. So I'm going to start here, and I'll do this one in blue. And I'm going to go in the positive direction like that. So I had the same starting line, the same ending line. So how do I get its value? Well, I went around one whole circle, 2 pi radians, and then I overlapped another pi over 3. So how do I add that? Again, 2 is 6/3 using common denominators. Pi over 3 is 1/3. And so I get 7/3 pi. That one went in the positive direction. Hey, the alarm went off. All right, so I have one positive and one negative example for coterminal angles. If we're doing those in degrees, this would be 360 instead of 2 pi. I showed you the more difficult one. All right, I think I will end part 1, and we will have to pick up with part 2 when we end today. I think I'll just do complementary and supplementary angles, and parts of a degree we will approach that next time, or as it comes up. So over and out for part 1. Go ahead and pull up part 2.